Hi, we're here at one of Cisco's R&D facilities in Research Triangle Park, North Carolina, to focus on a comprehensive suite of tests. Tests that were designed to verify new technologies that will empower the next generation of cloud services. Specifically, this year's mega test will focus on the needs of cloud service providers and the enterprise. Today we're looking at the Cloud Intelligent Network and how Cisco supports the transition to IPv6. Let's check in now with Cisco and our testing partners, EANTC. Our story begins, appropriately enough, via Cisco Telepresence, Cisco's cloud-based teleconferencing technology.
It's very important to understand that network itself is the platform on which you roll out the cloud services. If you look at the cloud services, whether it is within the data center where you are hosting most of the services, or you go between the data centers, or you want to actually offer those services to your end users, without the network, you can't actually go and offer those services. Without the network, you can't actually go and build those cloud services. Without the network, you can't actually connect between the clouds.
Sometimes data centers are heavily loaded in one region and less loaded in other regions. For example, if there is a major event in the US East Coast and people are watching TV and or specific streams on the East Coast. But on the West Coast, there will be services available. Now, NPS enables the service provider to offload some of those services to other data centers. It's basically data center interconnect technology where the service can benefit from the fact that resources are available in remote locations. Cisco's IPCF, Intelligent Policy Control function, which was implemented in the cloud as a virtual machine and delivered multiple individual policies to different subscribers, where basically we emulated a number of subscribers with the Ixia's IXLoad system, and these mobile subscribers were then requesting individual services which were provided with different SLA service levels. So scale is key when it comes to these IPv6 migration testing scenarios. We relied heavily on Ixia's IX network emulation capabilities here, and we started with 80 gigabits of traffic for all of these testing scenarios. In the first case, in the NAT64 test case, we tested a total of 60 million bindings, so 60 million network address translations, and that's a really humongous scale that the Cisco solution passed. In the second case, in the 6RD test, there was a total of 5,000 tunnels with 10 addresses each, which is also a large scale for these tunnel scenarios, which are more resource consuming. And in the third case, in the dual stick scenarios, we tested 1 million emulated subscribers. Half of them were IPv4, half of them were IPv6, and they were both sending traffic through the network in parallel. This scale relates to real-world requirements well into the future. So today, these numbers are not really used in the industry. There is quite a bit of headroom in the Cisco solution here, and this is especially important as we're moving to an internet with many mobile appliances and an internet of things with sensors and other devices that are not connected to humans.
You want to ensure that you have the right business continuity, especially for our customers, to ensure that as they move towards V6, they don't distract their existing infrastructure.
Once we had verified the basic IPv6 migration scenarios, the next step was to ensure that the dynamic address assignment would also work at large scale. So we tested a DHCP manager with many leases per second. The challenge here is not to maintain a large number of dynamically assigned addresses. The challenge is to assign them at a high speed, for example, after a network failure or in specific burst situations. We went far beyond this and looked into the application layer. We looked into virtualization aspects and everything, really everything that comes with cloud services delivery. And that made the test very complex. It made the test very time consuming. We spent 4 weeks in the lab. We spent 5 months in preparation. A really large Cisco team with multiple business units was involved. But also that's made the test pretty much worthy in terms of going far beyond what has been tested in the industry before.